And what I'm talking about is RCS. Rich Communication Services is an extension to standard telco calling and SMS. This is something that was standardized some years ago in 2008, but nobody really saw that until now Google and other operators in the US and Europe are pushing for this technology to be deployed everywhere. Okay, so now the question is this technology secure? Will be a good replacement for the broken ciphering and SMS? So will it protect your communication better than the old technologies? And I guess the answer is no. You will see later. For who thinks that this is completely new, I will give you a little bit of a recap of what are the attacks that we generally see in mobile networks, and then later a little bit of IMS and RCS, and then we will jump into the technical details of the attacks. Okay, mobile network attacks. I can classify all the types of attacks we found so far in 5 different classes. As you see there, the most important one being intercept. So of course everyone is interested in intercepting calls, SMS, other data communication, and this is possible. It's possible locally and it's possible remotely. Locally via intercepting radio or setting up an IMSI catcher, and remotely typically via SS7. Then the second attack that I can mention is impersonating users. So for example, sending SMS on your behalf without you knowing about it. This can be used also for fraud. Then we have tracking users, also very interesting. People are concerned about their privacy and disclosure of where they are. And in the GSM world, this is a very well-known problem, tracking via SS7 or also locally by sniffing the radio waves. And for criminals, it's of course interesting to commit fraud. So fraud can be 2 different things. Could be accessing some services without paying, or making you pay extra for the services. For example, sending SMS for free, or making you send an SMS to a premium number, and I will get the revenue from that premium number. And finally, DOS. DOS is not so popular, but it's possible, and it can be targeting a single subscriber, so disabling your mobile from receiving calls, or it can be disabling the whole network from operating. Okay, this was a large overview of all the possible attacks that were found before, and we will see how many classes we can cover in the new technology that is currently being pushed. Okay, so we want to mention here that several areas of the telco world have been fully covered, deeply researched, but not all areas have been researched. And we saw in the past SIM cards. Even recently, there was an attack about SIM cards. So I think now we reached a pretty good analysis of SIM cards. There should be some other things coming up maybe next year, but so far we did a pretty good investigation on SIM cards, all the radio channels, 2G, 3G, 4G, also femtocells, and then on the interconnect side, SS7 diameter, we really discovered almost everything that was possible. But in the middle of the network, there are still some nodes that are not yet fully analyzed. And especially, you will see this, this box in the middle, IMS and RCS, is what is our focus today. This is about IP telephony that is being deployed in networks because now voice calls are not existing anymore in 4G and will not exist in 5G. So how does this work? Well, if you remember, mobiles in the 90s were designed for making calls and maybe also send some SMS. Then later, after 10 years, people wanted to have internet. So internet was introduced in the mobile world, and it was a separate channel. So from the radio perspective, they are different things. And when 4G was introduced, voice calls were basically not very interesting thing for telcos anymore. So what happens over 4G radio channels is only data, only IP data. And how do you make calls? Well, the only way to make calls is over IP. So at that point, already in 4G, some operators switched on this IP technology called IMS, IP Multimedia Subsystem, to allow your phone to make calls over 4G. Some operators still don't have this technology, and that means whenever you want to make a call, your phone will switch back to 3G or 2G. But now let's move forward. So 4G and 5G don't have calls anymore, and you can make calls over IP. But there is one more technology that was designed to improve your experience in communication. And that is something that looks similar to what iMessage, WhatsApp, and Skype are, and this is called RCS. So RCS, as you see there in the picture, is a more fancy messaging tool where you can have these images and video and group chats and so on. And many operators in the world already deployed this technology without basically telling anyone, because this was the natural course of the technology. This should have been deployed already in 2012. Some operators were running trials, but it was not really pushed to customers because the phones were not supporting this technology yet. And what happened today? Well, we wanted to understand how is supported is this technology. So we conducted a survey. We started from the list of all operators in the world. There is about 900. And we looked up how many of them support 4G, so LTE. And it's about 1/3. So 300 operators implement 4G. In these 300s, how many do implement this voice over IP technology? Not all of them, but the majority of them. And then aside of voice over LTE, that is the main thing here, there is one more technology that allows voice over IP to be carried over any internet channel, typically Wi-Fi. So when your mobile is connected to your local Wi-Fi at home, when you make calls, those calls will be routed through your modem rather than the 4G channel. This is for operators to save some bandwidth. And now, the interesting part is how many do implement RCS? Well, we found through a DNS survey. So we know that there is a specific DNS domain that needs to be implemented, and we just crawled the internet for those domains, and we found about 100 operators that have these services online. And this is pretty good. And we found, well, there are some big groups of telcos that implement them already, and it's a good news for the technology because that means it's being pushed out. Now, if you want to know in which countries and what is the coverage, this is the result. So most countries, more developed countries, have this technology, at least in one operator. For example, in the US, most operators are implementing RCS. In Europe, some of them do. In Russia, everywhere, maybe in the development countries in development is not yet a thing, but it's coming. Some countries are also currently running some trials of this technology. Okay, so I completed the overview of the new technology that we will talk about and what possible attacks there are. I will start the analysis of the attacks. Starting from IMS. So this is not yet RCS. This is a technology that is the base, and RCS extends this technology. IMS can be converted into terms, VoLTE and VoWi-Fi. So the technology of voice over IP can be carried over LTE or over Wi-Fi, and they are different. What is the difference? That in LTE, the radio channel between your mobile and the network is a trusted channel, or considered trusted. So the voice over that channel goes unencrypted. This seems to be an issue, and maybe it is an issue, but since the radio channel is decently protected, I would not even call it an issue. But as you can imagine, if this would be the case for voice over internet, that would be a big issue. And well, luckily for the operators, this is, at least what we measured is that all operators and all mobiles, before they route your voice over the internet, over Wi-Fi, they establish an IPsec tunnel to a new node in the network called EPDG. And this IPsec tunnel makes sure that your voice will be at least encrypted once, and sometimes it's encrypted even twice, because over that channel, the voice could also be encrypted. So far, no real big attack, except this new node that was introduced, the EPDG, can be converted into an IMSI catcher. So what happens? This node has to talk to your phone, and your phone has to provide some identity in order for the other node to have the right keys, right? And identity in the mobile world means IMSI. So what we see there is a diagram of how the attack works. Your mobile, actually many mobiles already have this technology enabled by default. It's called like voice calling, or no, what's it called? Voice Wi-Fi calling, I don't know. You will find out if you go into your menu. or voice plus something. Um, what happens when your phone connects to a Wi-Fi? It's sending a DNS request to locate the EPDG. And if the Wi-Fi you're connecting to is our ROG hotspot, we can decide what is the answer to that query. And we can set the IP of the EPDG. And then from there on, it's pretty easy. The EPDG is really not a special node. It's just an IPsec termination point. So we can wait for the phone to connect to us, and then we say, okay, we want to speak the protocol that is used by telcos at 3GPP aka, please give me your identity, and the phone shares the IMSI. Done. So this attack is pretty scalable. You can just set up a ROG hotspot and wait for phones to connect to it, and then if they have this functionality enabled, you will collect IMSIs right away. We tested this with a Raspberry Pi, and we use open source IPsec implementation, Strong's one. With a couple of hacks, we could simulate an EPDG, and we got it. A similar attack was presented in 2016, but it was not as scalable as this one. And this is basically the only minor vulnerabilities that we found in IMS, so the basic IP, voice over IP technology. But now I will leave the stage to Sina that will tell you more about RCS, so the extended version of that.
Thanks, Luca. Okay, we saw a security issue in IMS. Now the question might be, okay, what about RCS? If it's possible to find some attack vectors in RCS or not? The answer is definitely yes. As you see, we could find different attack vectors in each of those categories that Luca already mentioned. For tracking user, impersonation, fraud, and loss, the attacker doesn't need to have any specific information or access. It's just needed to be connected to the network, and then you can perform one of those attacks. For the last one, interception, attacker would need to first retrieve the victim's config file. I'm going to explain later what that config file is and how we can retrieve it. And also, not all mobile operators are vulnerable to all of these attacks. Let's start first with user tracking. Both IMS and RCS use SIP as their signaling protocol. In SIP, there is a functionality that you can see if another user is available or not by sending SIP options. In this case, attacker would be able to just prepare a list of numbers that he wants to enumerate and see if those users are available or not. Then just send SIP options to the RCS score. In case the user is available, the reply would be 200 OK, including some information. If user is not available, the reply would be not found. And since there are interconnections between operators for IMS and RCS, this attack is scalable. So that means attacker would be able to even request other subscribers in different networks and even different countries. Once the attacker receives 200 OK from a user who is online, that SIP information, that SIP packet involves information such as user's IP address and the device model. Based on the IP address, attacker would be able to roughly find the user's location by using IP geolocation databases, especially if that IP is IPv6. We have also found different ways to retrieve the user's IP and find the user's location that I'm going to talk about later in this presentation. But for now, let's move to impersonation and fraud attack based on RCS. There's a really well-known and old attack in SIP which allows attacker to spoof caller ID by just crafting a SIP invite. We didn't expect that attack still exists in this new technology, but surprisingly we could find some networks that are still vulnerable to this traditional and old attack. How this attack happens, first the attacker needs to register to the RCS score. Afterwards, he can craft SIP invite message. SIP invite is used to establish a call or sending a message and just spoof the SIP headers and do impersonation attack. It can be any other numbers or even premium numbers or a phone number which is expensive to be called. So if the victim is curious enough, he would call back and it's going to charge him a lot of money, probably. Besides of this traditional attack, we could find other security issues in RCS. The fact is that RCS core recognizes the registered user only based on the public IP address and the username. Username is always the phone number of the user. So if attacker and victim both share the same public IP address, RCS core wouldn't be able to recognize a legit request and a crafted request. So in case, for example, attacker and user are both behind the same VPN, or they are using the same NAT, or a Wi-Fi access point ran by attacker would be able to use this security issue, send a crafted message, SIP message to the RCS core, and since both they use same public IP address, RCS core wouldn't be able to detect this attack. Let me explain this with a demo video to show you better. Okay. Here we have a Wi-Fi access point run by attacker. We see traffic and we see a screen of our victim device and the victim friend. So victim first connects to the attacker access point, and immediately after that, the phone tries to find a PCS address and tries to connect to the RCS core. As we see here, it automatically happens after connecting to the internet. Okay, as we see, the connection is over TLS, so we cannot see any information. On the right hand, we see we are monitoring the existing conversation between the victim and a friend. Here, we have information about PCSCF that victim is connected to. So we know the IP address and the port number. We already developed a tool that receives a sender and receiver phone numbers, PCSCF IP address and port, and you can give it a message that it will deliver via SIP invite to the RCS core. It takes a few seconds, and as we see here, RCS core accepted our message, and it couldn't recognize that it's a fake and crafted message because attacker and victim both are using the same public IP address. And as we see, the message was delivered to the receiver that we wanted. Okay. Let's move to the other functionalities in RCS. There is a feature in RCS like other messengers that you can transfer file, like video, image, stuff like that. And the way it works in RCS is that first the client uploads that file, for example, an image, to the file transfer server. That server replies back with the XML confirmation. That XML file contains two URL. One is the thumbnail URL, and one is the URL pointing to the actual file that client uploaded. Once the client have that XML confirmation, it sends that confirmation to another party. Once the receiver receives that XML confirmation, the RCS client automatically tries to download the thumbnail and show it in the conversation. So what happens here? An attacker is able to find a target, for example, for DDoS, find a large file on that target, craft an XML confirmation, and put that large file as a thumbnail URL, and send that XML confirmation to lots of subscribers. Once those subscribers receive that XML confirmation, which means a media file, RCS client automatically tries to download the file, and it will be the DDoS attack against of that target. Also, as I said, there is another way to abuse this feature to track user and find information about device. Attacker also is able to put a URL pointing to his own server as a thumbnail URL and send it to a victim. So once the victim receives that message, again, RCS client tries to download the thumbnail, issuing an HTTP request to the attacker server and reveals the IP address. So again, attacker would be able to roughly locate the victims based on the geolocation, IP address geolocations. Another issue that we could find in this feature of RCS, surprisingly in some of RCS clients, specific RCS clients, it turned out that FT server requires the client to be authenticated. So the client needs to attach session token to the HTTP request and send it to the FT server. In that case, again, attacker would be able to craft a URL pointing to his own server, send it to the victim. Once the victim receives that, starting downloading the thumbnail automatically, and the client would reveal the session token, and attacker would be able to take over the account of victim completely by that session token. Okay, let's move on. We saw fraud attack, DDoS, impersonation. Now we need to see, okay, how we can do interception. There are two different attack scenarios for interception in RCS. First is based on XCAP. XCAP is an interface in RCS which is used to set call forwarding. We could find different ways to abuse this and set call forwarding the same as SS7. I'm not going to talk about this attack scenario in this presentation, but we are going to focus on the second attack scenario based on the RCS provisioning. We could find 4 different ways to abuse security weaknesses in RCS provisioning to do interception attack. Let's first see how RCS provisioning works. Provisioning means configuring the credentials on the user's device so that the user would be able to connect to the RCS core and uses the services. At the first, RCS client issues an HTTP request to the config server, and config server replies with a session ID and sends an OTP via SMS to the user. On the second request, which is HTTPS, client sends that OTP and session ID. If all information is correct, the config server will return the XML configuration file. Okay, in this situation, if there's a malicious app on the phone, the malicious app would be able to abuse the LTE connection of the device, retrieves the config file, and uploads it to the attacker server. The question might be, okay, what if we cannot make the victim installing a malicious app on the device? It's also possible if the victim is sharing the internet via hotspot to the attacker. So attacker behind the hotspot of the victim would be able to again abuse the LTE connection, simulate the provisioning process, and retrieves the config file by hijacking the identity of the user. Again, maybe the question is, we don't have any interact with the victim. Is there any other way that we can retrieve the config file of a user or not? We already thought of that, and we could find other ways by having a malicious access point. In this case, malicious access point injects some malicious JavaScript to the browser of the user that retrieves the config file and uploads it to the attacker server. Let me elaborate on this attack scenario with the demo, because it might sound complicated like this. So, okay, here we have an access point run by attacker. On the right side of the screen, you see the victim's device. So, victim connects to the internet through the Wi-Fi run by attacker, and then start browsing the internet. So, here, done. Attack is done, and as you see on the left side of the screen, we retrieve the config file, but maybe you didn't notice what happened here. Okay, victim started browsing internet. The access point retrieved the actual content that user wanted to browse, injected malicious JavaScript payload to the content, return it to the victim, and immediately disconnected user from the access point. So phone falls back to the LTE connection, but the malicious JavaScript still is running on the device. That JavaScript code retrieves the config file by using the LTE connection and uploads that config file to the attacker server. Now we could get a config file uploaded to our server. Let's take a look and see what we have here in the config file. At the beginning, we see a token which is masked in this video because that is really critical value in the config file. Once the attacker has this OTP, attacker will be able to retrieve the config file anytime in the future without needing for OTP confirmation or any other validation or confirmation. After that, we see phone number of the victim that we already retrieved his config file. And here, we see a set of credentials. This set of credentials is used to connect to the RCS core. Once the attacker has this credential, that means he will be able to do anything on behalf of the victim and completely take over the account. If we scroll a little bit down, here we see another set of credentials which is used for uploading media file to the FT server. And there are also lots of other parameters here which are not really interesting for our attack. Okay. Getting back to our slides. Beside of that, okay, all of these attack scenarios are kind of local, and there might be even OTP verification. So the question is, what if the network operator implements OTP verification? Surprisingly, sometimes it's possible to brute force OTP if the network operator doesn't have any rate limit on OTP validation. At the first step, the attacker would need to find valid IMSIs. This can be done by issuing HTTP requests to the config server. And config server would reply with different HTTP status code based on the validity of IMSI. As you see here on the top right screenshot, we could find three valid IMSIs, and the config server replied with 200 OK for valid IMSIs and 403 for invalid IMSIs. Once you have the IMSIs, valid IMSIs, the attacker would be able to brute force OTP, and if the network is vulnerable to that OTP brute force attack and doesn't have any rate limit on the number of times that someone is able to send OTP, attacker would be able to retrieve the config file after finding the OTP, as we see here on the another screenshot. We saw 4 different ways to abuse RCS provisioning to retrieve a victim's config file. Now it's time to use or abuse this config file to do interception attack. Once the attacker has the config file, the victim is connected to the network normally via LTE, RCS, or any legacy network. On the other hand, attacker uses the retrieved config file to connect to the RCS core via internet. While the attacker is connecting to the RCS, he makes sure that he sets SMS over IP flag that tells the RCS core this instance is able to receive SMSs over IP via SIP. Afterwards, attacker will wait for incoming SMSs. What happens when you receive an SMS? Someone wants to send you an SMS. For example, your bank wants to send you an OTP via SMS. SMS will arrive to the SMSC. SMSC asks your home network where this message should be delivered. Since there's an instance active that is able to receive SMS over IP, this SMS will be forwarded to IP SMS gateway. In that node, the SMS packet will be converted to IP packet, and after that, it will be delivered to the attacker by a SIP message. Once the attacker has the SMS, he can decide if he wants to acknowledge the message or not. If attacker acknowledges the message, the network doesn't deliver that SMS to the actual user. Otherwise, the real user will receive also the SMS. When we were working on this attack scenario, we were thinking, okay, what would be the case for abusing this scenario? And the first thing came to our mind was to taking over a Gmail account by retrieving the OTP for password recovery. Let me show you how we exploited this vulnerability here. Okay. So we wanted to take over a Gmail account, and on the right hand you see the victim's screen. So we have started the password recovery process, and definitely we didn't know the password. So we just asked for an SMS, and we had a tool that could connect to the RCS core by using the victim's configuration file and waiting for SIP messages. So here we ask for OTP over SMS, and after a few seconds, the OTP was delivered to this instance by a SIP message because we set the flag to getting the SMS over IP. And as we see here, we could get the OTP for retrieving the password for Gmail account as a SIP message, and we see that victim will also receive the message because we didn't acknowledge this message. And then using the OTP to just continue with the password recovery process and set a new password that could give us the opportunity to take over the victim's account completely. Yeah. And there we go. Completely taking over the account by just receiving an OTP. So,
this is really surprising. When we discovered this, we thought, no, it's not possible. But in fact, not all networks are vulnerable to this attack. It depends on these flags that you can set in the network, but we could find a way to just do it. Once you download the configuration file, you receive the SMSs on behalf of the user, and you can decide to do whatever you want. Okay, so if this was, if this was maybe alarming, I want to give you some good news. There are some mitigations. And these are not very sophisticated, actually. These are 7 or 6 best practices that we just wrote down. These are kind of known best practices that just operators did not implement correctly, or not implement at all. Starting from that RCS file that we saw being retrieved, how can we prevent that? Well, we have to harden the provisioning phase. How do we do that? Well, we need to verify the client before we deliver the file, and there is a way in the new version of RCS that allows this pretty securely, and this authentication is based on SIM card. So it's really hard to fake a SIM card or to brute force anything related to the SIM card. This technology exists, so mobile operators should switch to this technology, the first item that you see there in the list. In case they cannot implement this because their RCS version is older, so RCS 5e, they should definitely implement OTP. We didn't say, when Sina was explaining the provisioning, he said there was OTP, but it's optional. So some networks do have OTP, some networks don't. So we definitely recommend OTPs to be in use, and pretty strong OTPs, not 5 digits, not even 6 digits. You can set it to 16 digits and alphanumeric, so make sure that it's not brute forceable. And then one more criteria that needs to be applied is, of course, the rate limiting. Definitely there is no reason for accepting thousands of requests. Let's say 5 would be already a good number. So let's allow the mobile to fail sometimes, but after 5 attempts, basically we invalidate the OTP and the process has to restart from scratch. This was to protect the RCS configuration file, but we saw other attacks that were involving spoofing caller ID and so on. How do we mitigate those? Well, on the network side, there is a node that takes care of your incoming traffic, the PCSCF, or called also SBC. That node should validate the fields that you as a client pass to the network. And specifically, the identity should be verified and replaced by the PCSCF so that you cannot spoof your caller ID. This also applies to the second attack where we were behind the same NAT. At that point, the PCSCF should verify that the client has a single TCP socket, and if you connect on another socket, that's a completely different client. It's not the same client. So verifying the identity of the client at the network level. Then we saw there was some information leakage, this token bearers and the IP in the request. Well, definitely our recommendation is to mask those values from the network point or not send them at all from the client side, because as we saw, that allows taking over accounts. And finally, to protect again the DOS on the file transfer server, that infrastructure should work in a combined way. So when you upload a file, the network should know the file that you uploaded and only accept the link to that file and not just a random URL that you provided. So 6 simple rules that should be implemented by operators, and we are pretty safe. And to conclude, we were definitely surprised when we analyzed this technology. We thought, okay, it's new. There are really good measures, TLS, SIM-based authentication. There should be security in there. And we found that not all implementations are broken, but many had at least one of the bugs that we were showing. So in 5 areas, we found at least one bug in each network. Okay, the recommendation is, of course, for this presentation today to be visible, to let the operators work on this and fix these issues. One thing that maybe was not super clear, when Sina was presenting, there was a mobile there, and that was not an app that we installed. That was the default Android messaging app. So by default now in Android 9 or future, the messaging app supports RCS by default. You insert a SIM card on a phone, and the phone retrieves the configuration file, and you are set up. You are inside RCS. So this is, the issues that we reported today are really currently valid. It's, well, it will take some time for operators to fix them, also from the Google side to implement some other fixes on the client side, but we hope that this will happen soon because the technology has been already rolled out. I also encourage you to, as security researchers, to explore the telco world a little bit more. As you saw, there were some boxes in the core that were not explored yet. Of course, we are doing that, but I encourage you to do the same. And it's all over IP now, so please go and hack the world. And just to finish, I wanted to thank all the people that worked on this research in SL Labs, especially Lucas Euler and Martin Saar. And I'm happy to take questions.
Questions, anybody, for Luca and Sina? Just raise your hand. So if there are no questions, thank you again for your interesting talk, and we'll be back at 11 sharp after the coffee break.